Hello everyone, Dr. Vaughn. We're going to go over this time 13.5 Excel Activity 1B. I think this is the very last one. And here we're going to do a different kind of ANOVA. This is going to have multiple factors to it. You could watch this video if you want for their take on how to do this problem. But what I did is, and you can see I kind of already have the answers typed in here. So I opened up this spreadsheet. And instead of doing it in this online one, because again, I don't have the data analysis tool pack installed here, I just copied and pasted all of these data out of this online Excel spreadsheet into just a standalone Excel spreadsheet, which you'll see right up over here. So in the top left, I just pasted in all of the data, widened these a little bit so that I could read all of these things. Here's the important thing. The make model doesn't really matter. What we're looking at is the class of the car, and there are 4 different classes, and then the types. So we're going to rewrite this data into a 2-factor ANOVA table. So we're going to put the small car, the mid-size car, the small SUV, and the mid-size SUV along the left-hand side. And I'm leaving a space because each one of these, small car hybrid, has 2 different data values. And then I'll separate the hybrid from the conventional. So I first put the labels in, small, medium, mid-size, small SUV, mid-size SUV, hybrid, conventional. And then I started typing in the numbers, 37 and 43. And then for the conventional, 29 and 33. Right? And then I went to the mid-size car and typed in the numbers 28 and 31. And then I typed the 24 here and the 24 here. Okay, so you fill out this table. It's all the same numbers, but it's arranged so that you have one factor on the left and the other factor across the top. All right, so that's the first part. It's just kind of reframing the data into this 2x2 contingency table. And then the next thing I'm going to do is run this 2-factor with replication. With replication because there's more than one data value in each one of these 2x2 cells. There's a 37 score and a 43 score. Right, so I'm going to run the data analysis tool pack, and I'm going to go to 2-factor ANOVA with replication. Right, so when you run that, now on the input range, and this is very important, it took me a long time to actually learn this many years ago, is that you want to start with the big blank cell up over here, and then drag over and down, so you have both the labels and the data. And then you have to fill in this number with there's 2 rows or 2 data items in each one of these cross references. So hybrid small car, there's 2 data scores that go with it, and they're arranged into in 2 different rows, row 1, row 2, row 1, row 2, row 1, row 2. All right, and then you put in the alpha value, which is 0.05, and then where do you want the output to go? So I just put the output over here to the right, and then I pressed OK. Now, I've already done it, so I'm not going to redo it, but you'll get over here a summary. And this is going to go, type by type, hybrid small car, how many there are, the average, the variance, mid-sized car, hybrid. And then it'll go over to small and SUV and mid-size SUV. All right, and then it'll give you the kind of the overall count, and then it gives you the Anova table. And the Anova table has everything that we need on it for this problem. All right, so we're going to have the sum of squares and the degrees of freedom and the mean squares and the F values and then the P values. And these are arranged into what on here says sample, columns, and interactions. Over here, they're going to call it class, type, and interaction. Class is the same as sample, and type is the same as the columns. All right, so you're just going to pull these numbers off of this table one at a time, 435.5, 196, 7.5, 3.5, and the total 692. Then the degrees of freedom, 3, 1, 3, 8, and 15 in the next column. And then you're going to put in the mean squares, and then you're going to put in the F value to 2 decimal places. All right, so that's going to be all of this section right here. And then we're going to go one by one for the class, which remember is called sample in Excel. So we're going to go to the sample and pull out the P value. Now this is 6.3 times 10 to the negative 5, so that's practically 0. It's 0, 0, 0, 0, 5 zeros and then 6 threes. So 4 decimal places, it's 0. So I just put 0 in over here. And since P is less than alpha, we can conclude that there is evidence that the class of the vehicle is not the same. the fuel efficiency is not the same among the classes, like midsize SUV, small SUV, etc. The next one we're going to look at is type. The p-value for type is 0.00015, which rounds to 0.0002, and that is less than alpha as well. So we'll conclude that there is evidence to conclude that it's not the same for the types, hybrid versus conventional. And then the third one is about interaction, and the interaction is 0.6945 when you round it to 4 decimal places, and that is not low. That's not less than alpha, and therefore we conclude that there's not evidence of interaction between the two. So although there's a difference between the class of vehicle and there's a difference between the hybrid versus conventional, those two factors are not interacting with each other. That wraps up our very last kind of ANOVA problem, factorial experiment. This is about as hard as it gets, folks. I look forward to next week, our last week together, week 5, where we'll kind of wrap up doing some different kinds. It's not more of comparing means like the t-tests and the ANOVA have been, but we'll look at more qualitative data and looking at chi-squared and distributions and a few other kind of topics to wrap up this class. All right, I'll talk to you again soon. Thank you very much for watching.